And we are live. Okay, this is Doug. It's algebra class. It's going to be fun. We're getting to the basics of algebra that are so important. I'll talk later about why I think this is so important, this stuff. We started last week and we did some examples, and now we're going to start getting into doing a lot. We want to be able to do a lot of practice because we want to be very comfortable with this. Algebra is a simple concept behind it. X is a number, I don't know what it is, but if I do my algebra, the answer will say X equals, and I'll know what it is. Sometimes with simple examples like these, you can sort of look at it and figure out what X has to be, but we want to be able to show that we can prove what X is. We want to be able to show how we found out what X is. So we don't want to just look at it and do the work in our heads. We want to be able to show what it looks like. Let's look at this one. We are adding a number to X. This is what I'm starting with. All of my first 4 examples, I'm adding a number to X. I want to be comfortable with the adding to X thing before I start the subtracting and then the multiplying and then the dividing. And this is what makes algebra look easy, but not be that easy, because what you have to do depends. Am I adding something to X this time? Am I subtracting? Am I multiplying? Am I dividing? The steps that you do are slightly different depending on which operations are happening. And you can get to algebra expressions where there's more than one operation happening to the X. Then you have to go through a series of steps of algebra to solve it. What is the basic step? We talked about this last lesson. X plus 7 equals 12. I'm adding 7 to X. I don't want my X to have things with it. I want X to be alone on one side of the equal sign. So how do I get rid of this plus 7? Well, the opposite of adding is subtracting. So if I'm adding a 7 to my X, I want to subtract a 7. So I do X plus 7 minus 7 equals 12. Yeah, minus 7. Why did I do that? Because the rule of algebra is if you're going to subtract a 7 on this side, you have to subtract a 7 on that side. If you don't do that, if you subtract a 7 from only one side, what you're doing is you're changing the question. So we don't want to change the question. We want to find out what this X is, and this is our question. If we subtract from both sides, then we're not really changing it, because what we did on the right side is equal to what we did on the left side. That means we're following the rules. So if I add 7 and subtract 7, well, that means these two cancel. And X is now alone, which is what I want, and it's equal to 12 minus 7, which is 5. Yes, the students could look at this and think, oh, I think it has to be a 5 that goes there. But now we see a way of showing that it's a 5. I didn't really leave very much room. I'll put a squiggly line here so that I have more room for my examples. X plus 5 equals 18. I'm doing the same thing. I'm adding a 5 to my X. I don't want the X to have that plus 5 with it. I want the X to be alone. How do I get it alone? If I'm adding a 5 to it, I'll subtract a 5. But if I subtract a 5 on the left side, I want to subtract a 5 on the right side. That's allowed. These cancel. X is now alone. And 18 minus 5 is 13. I have my answer. It really is this easy. And if only it were always going to be this easy, but remember, I have warned you, sometimes we're adding a 7 to X, sometimes that's not what we're doing. We have to be ready to deal with all sorts of situations that the algebra question gives us. But we'll practice this one some more. X plus 3 equals 6. My X has a 3 added to it. I'm going to make it be alone by subtracting a 3. But if I'm subtracting a 3 on the left side, I want to subtract a 3 on the right side. These cancel. X is alone. And 6 minus 3 is 3, and I have my answer, yes. And of course, I can verify my answer. I can say, hey, if X is 3, this should make sense if I replace X with a 3. There's some of that plugging, that substituting that we talked about last time as well. If X is a 3, then 3 plus 3 equals 6. Yes, that makes sense. All of them are verifying. If X is a 5, 5 plus 7 equals 12. It makes sense. X is a 13, 13 plus 5 equals 18. It makes sense. This works. We know it works. Now here I'm adding a 9 to my X. I want my X alone, so I will subtract a 9. But I have to subtract a 9 from both sides. Uh-oh, this time I have a negative 2 on the other side. It doesn't matter. I still do the step the same way. So instead of subtracting a 9 from some other number? Well, I'm just subtracting a 9 from the number that was there, which is a negative 2. These cancel. X is alone, and it's equal to negative 2 minus 9, which is negative 11. And we get to see why students have to learn their integers before they start learning their algebra, because negative numbers happen a lot in algebra, and you have to just not be afraid of them. So that's my first 4 examples. They all involved adding something to x. Let's do some subtraction examples. I'll do some erasing. Okay, let's put some subtraction examples. And I'll try and leave a bit more room this time so that we don't have them crowded together so much. So how about x minus 2 equals 1? Nice small numbers to deal with. How about x minus 8 equals 4? Again, we can look at this and we can sort of see what the answer is going to be if we have a good feeling for numbers. Something minus 2 equals 1. Well, I think 3 minus 2 equals 1. We can figure out what the answer is going to be, but we want to show what the answer is. Putting it a little lower this time, x minus 10 equals 110. I'll put in some larger numbers just to prove that, well, once you know a trick that works, when you get questions with bigger numbers, it doesn't matter, the trick still works. How about we put in another negative number on the other side of the equal sign like we did in one of our examples with the adding. So x minus 5 equals negative 3. How about it? Okay, let's do it. Okay, I am subtracting a 2 from my x. I want the x alone. That part's the same, but wait, this time I'm subtracting a 2, so I'm not going to cancel that by subtracting a 2. I'm doing the opposite. With adding, when I was adding a number, I subtracted the same number, because adding and subtracting the same number, they cancel out. It works. This is why we're doing it. So if I'm subtracting a 2 from my x, and I want my x to be alone, I have to do the opposite, which is I have to add a 2. And if I'm adding a 2 on the left side, I have to add a 2 on the right side. These cancel. See, a lot of these things are the same with the subtraction as the addition. X is equal to 1 plus 2, which is 3, which we predicted. X minus 8 equals 4. I am subtracting an 8, so I'll do the opposite. I'll add an 8, but I have to add an 8 to both sides. Okay, the minus 8 plus 8 cancels over here. X is alone. 4 plus 8 is 12. It works just as well as the examples where we had things added to x. Subtraction and addition aren't that different when we do this. But we need to practice both of them. Because if we only practice one of them, then we'll be surprised when we see the other one and we might make a mistake. Here we're subtracting a 10. I want my x alone, so I will add a 10. I'm going to add a 10 to both sides, and yes, adding a 10 to a very large number is still fairly easy in math, so minus 10 plus 10 cancels, my x is alone, that's what I wanted. 110 plus 10 is 120, I have my answer. X minus 5 equals negative 3. I want my x alone, so I will add a 5 to both sides. This didn't erase very well, so I'll erase it a little more. There. Okay. So I'm adding a 5 to both sides, minus 3 plus 5. The fact that I had a negative 3 isn't bothering me, and I can add a number to a negative number. I know how. The minus 5 plus 5 cancels. My x is alone, and negative 3 plus 5 is positive 2. Hey, I got a positive answer. That's just fun. Verifying. 3 minus 2 equals 1. I'm replacing my x with the number that I said x was equal to at the end. 3 minus 2 equals 1, it verifies. 120 minus 10 equals 110, it verifies. 12 minus 8 equals 4, it verifies. 2 minus 5 equals negative 3, oh, integers, but it verifies, no problem. So we have found some tricks that work. We have addition, and we have subtraction, and we know what to do. We need to practice. But the good thing is, it's really easy to make up these questions yourself if you need them. You can find lots of pages of exercises that have this stuff, but you can also make up the question yourself. And I think making up questions yourself is one of the most powerful things that a student can do, because it might be easy to answer a question without understanding it that well, but it's not easy to make up a good question unless you understand it well. So that really helps to elevate your understanding. I encourage it. getting my microfiber cloth, I'm going to do some erasing because what's next after adding, subtracting? Let's try some multiplying. Okay, when I say multiplying, I say, let's try some examples where my x is being multiplied by a number. 3x equals 18. There we go, we have an x. It's a number, we don't know what it is. How do we find out what it is? We want the x to be alone. It's not alone, it has a 3 with it, but that 3 is not being added to it or subtracted from it. Now the 3 is being multiplied by the x. I'm going to make my x a little bit bigger. Okay, 3x, but that's just one example. I'm going to make up 4 examples like I did with the others. How about 2x equals 20? How about 5x equals, I'm going to do something a little interesting with this one and say 5x equals 13. How about 8x equals negative 48? There's a negative number. I wanted to throw one of those in. Okay, so my x is being multiplied by a 3, and I don't want the 3 there. I want the x to be alone. So I do the opposite. What's the opposite of multiplication, though? It's not subtraction or addition, it's division. So if my x is being multiplied by a 3, then I'll divide the x by a 3, because that's the opposite of multiplication, and these are going to cancel. But if I'm dividing the left side by a 3, I have to divide the right side by a 3. These cancel. X is alone, and it's equal to, oops, I wrote an x here, and I meant to write a 3, so let me correct that. 18 divided by 3 is 6. It works. Doing the opposite. I keep doing the opposite. The opposite of addition was subtraction. The opposite of subtraction was addition. The opposite of multiplication is division. The opposite of division is, I think you can figure that out. Okay, 5x equals 13. Now I'll do that next because I want to do another easy one. 2x equals 20. My x isn't alone. I want it alone. It's being multiplied by a 2. The opposite of multiplying by a 2 is to divide by a 2. I divide both sides by a 2. Anything I do on the left side, I have to do on the right side. These cancel. X is alone, and 20 divided by 2 is 10. I have my answer. Here's one that I'm going to have to slow down a little bit because I'm not creating a super easy answer that I know will give a convenient, I'm not creating a super easy question that I know will give a convenient answer. But it's not very much more inconvenient. 5x equals 13. My x is not alone, it's being multiplied by a 5. I want it alone, so I do the opposite. I divide by 5. I divide both sides by 5. What I do on the left side, I have to do on the right side. These cancel. X is alone. 13 divided by 5 is 2.6. So all this stuff that I did to learn decimals is coming in handy. 13 fifths was a good enough answer if you think about it. It's a fraction. 13 fifths is a number which is equivalent to 2.6. So I didn't have to go into decimal form. I could have left it at 13 fifths. I could have converted it into a mixed number and called it 2 3/5. So there are several different ways of giving the right answer, but this is one of them. Okay, it works. The fact that it gave me a decimal at the end didn't change anything. It didn't change the rules that I was applying, the steps I was doing. 8x equals negative 48. I have a negative sign over there, but I'm not worried. That hasn't bothered me in the previous examples. My x is not alone. My x is being multiplied by an 8. So I do the opposite. I divide both sides by 8. These cancel. My x is alone. I'm making sure this fits in the rectangle of the video. And negative 48 divided by 8 is negative 6. I have my answer. It works just as well as the addition and subtraction. Verifying. If x is 6, 3 times 6 is 18. That makes sense. If x is 10, 2 times 10 is 20. That makes sense. If x is 2.6, 5 times 2.6, it is 13. If I have to get out pencil and paper to multiply, or if I use a calculator, or if I'm able to do it in my head, and if I had kept it in the fraction form, I'd still be able to verify. If x is negative 6, 8 times negative 6 is negative 48. A positive times a negative is a negative, so that makes sense too. So having negative numbers doesn't matter. Having answers that work out the whole numbers isn't necessary. Algebra is powerful. We can do an awful lot with it. So let's do a few more examples. Now I'm going to slow down. I'm not going to jump right into division. I'm going to do some more with multiplication. Erasing. How about if my x is being multiplied by a number that happens to be a fraction? I can still do this. So let's do a few of them. How about 2/3 x equals 18? Nice and challenging. How about, oh, and these are both simplified fractions. Neither of them is an improper fraction or a mixed number, but I can do some improper fractions. So how about 5/4 x equals 25? Can I still do it? I think so. And let's throw a negative number in there. Let's throw a negative number on the side of the x this time. How about negative 3/4 x equals 40? Okay, I have some examples. Let's do them. That one I wrote kind of high. All right, my x is being multiplied by a number. I want my x alone, so I will do the opposite. I can divide by the number. I can divide by a half, and that will work. But another way of looking at this, because we know something about fraction, dividing by a half is the same as multiplying by 2/1. We know this because when we learned to divide fractions, we had to learn that. So instead of dividing both sides by a half, if I want, I can multiply both sides by this fraction upside down, the inverse of this fraction, 2/1. And if I'm going to multiply the left side by 2/1, I'm going to multiply the right side by 2/1. It's going to work because 2/1 times 1/2 will cancel. These cancel, my x is alone, and 10 times 2/1 is the same as 10 times 2. It's 20. Does it make sense? Let's verify right away. If x is 20, half of 20 equals 10. Yes, it verifies. It makes sense. Let's do this one. 2/3 of x equals 18. I'm going to multiply. I think I prefer to write it again. I don't want to go fast and not use much paper or chalkboard because students are still learning, so I want to show the steps. So 2/3 x equals 18. I'm doing the opposite of multiplying by 2/3, which is multiplying by the inverse 3/2. So I'm multiplying both sides by 3/2. I'm still applying the same rule of algebra. What I do on the left side, I have to do on the right side. The opposite of multiplying by 2/3 is multiplying by 3/2. It could also be dividing by 2/3, but there's more than one way of showing the opposite of multiplying by 2/3. 3/2 times 2/3 cancels. I can cancel it in pieces if I want. I'll try that over there. These cancel, so therefore my x is alone. Does this still fit? I can't tell. I can't see very well. I think it fits though. X equals 18 times 3/2. Okay, I have to slow down. 18 times 3 is 54, divided by 2 is 27. Now I can see if it fits, and it does fit. Does it verify? 2/3 of 27 equals 18. Yeah, actually that does verify. 18 is 2/3 of 27. It works. I wanted to show the canceling for this one. So I'm going fast when I say 2/1 times 1/2. I'm just crossing them both out because I know they will cancel. But here I'm going to slow down. I'm going to show the canceling. So 5/4 x equals 25. I'm going to do the opposite of multiplying by 5/4, which is multiplying by 4/5. But I have to do on the right side what I do on the left side. Now showing the canceling, when we learn to multiply fractions, we learn canceling. The 4 on the top cancels with the 4 on the bottom, and that leaves 1s. The 5 on top cancels with the 5 on the bottom, and that leaves 1s. But all these 1s are just going to simplify to be 1, meaning my x is alone. 1x, it's alone. So showing it this way, it also makes sense. 25 times 4/5. I can show this with canceling as well if I really want to. I can turn 25 into a fraction by putting it over 1. We do that a lot. I can cancel a 5 between this 5 and this 25. So if I divide both of them by 5, I have 1 here, and I have a 5 there. 5 times 4 is 20, and 1 times 1 is 1. So my answer is 20 over 1, which is equal to 20. Can it verify? Let's see. 5 fourths times 20 equals 25. This might take a little bit more time, but I can say 5 times the 20 is 100 divided by 4 is 25. Yes, 5 fourths times 20 is 25 does verify. So some of these you see I'm slowing down a little bit. Some of them do slow you down. When it's time to slow down, slow down. When they're really easy, you can churn through them really quickly, but when there's things that can trip you up, slow down and be careful. Negative 3/4 x equals 40. I can multiply negative 3/4 by the upside down version of the same fraction, which is negative 4/3. So the fact that negative sign was there isn't really bothering me. If I'm multiplying this side by negative 4/3, I have to multiply this side by negative 4/3. These will cancel. I'm not going to show all those little crossing outs. I'm just going to say 4/3 cancels with 3/4. And negative times negative cancels as well. Multiplying a negative and another negative gives a positive. So we just have x left. And 40 times negative 4/3, sorry. Positive times negative, I know my answer is going to be negative. 40 times 4 is 160. 160 thirds. Now I can express this as a mixed number. I can express it as a decimal. But this is a correct answer. And I can verify it. Verifying it might be a little bit more slow. Negative 3/4 x equals, I'm not going to verify it, it would take too much chalkboard space. But it does verify. Let's move on to doing, I want to look at something in my list of examples here. Normally I have that on a piece of paper, but this time it's on a computer screen. Okay, the thing I want to do next is I'm going to give us some, still not moving on to the division. I'm going to give us some slightly larger questions where we have to consider like terms. That's what I'm going to do. I'm going to do a couple of those examples. I think I might stop using so much of the space way down here at the bottom because it's hard for me to write down there and it gets messy. So maybe I'll put less examples at a time. As we move on to the more challenging things, throwing 4 examples on and doing them really fast starts being a situation where I have to slow down. So how about 3x plus 2x is equal to 40 plus 10. So it's bigger, but it's still doable. Now, do I want to try and make this x be alone? Well, it's too soon to do that because I have an x here and I have an x there. Oh, okay, so trying to make the x alone, for instance, by dividing everything by 3, that would help make this x alone, but it's not going to work very well with that. It's because I'm doing things in the wrong order. What I need to do is when I can simplify, before I start going on my algebra tricks, I'm going to do it. And this is just combining like terms. 3x plus 2x is 5x. Not so bad. And 40 and 10 are also like terms. They're both constant terms. They both have number without a variable. 40 plus 10 is 50. Well, suddenly I've turned it into one of those easier questions we were doing before. My x is being multiplied by a 5. I want to do the opposite of multiplying by 5, so I will divide by 5, but I have to divide both sides by 5. Interesting thing when we stop and look is, what we did here, is it the same as what we did there? It is, because what we did here was combine like terms, and what we did there was combine like terms. So what I did on the left side, I did on the right side. Would it always be like that? Let's find out by doing another example, but I'll finish this one first. So these are going to cancel. X is alone. 50 divided by 5 is 10. We have x equals 10. We have our answer. It took just a little bit longer to get there. If x is 10, will it verify? 3 times 10 is 30. Plus 2 times 10, which is 20. 30 plus 20 is 50. And we know 40 plus 10 is 50. It is verifying. It works. So combining like terms is useful. What if we had 10x minus 2x equals 88. Am I going to combine like terms on both sides? Well, no. I'm going to combine like terms on the left side because I need to, but I only have one term on the right side. So you don't always end up combining like terms on both sides. You have to be flexible. You have to do it when you have an opportunity to do it. 10x minus 2x is 8x. And 8x equals 88 is like one of the early examples that we probably find pretty easy by now. My x is being multiplied by 8. I want it to be alone, so I'm dividing by 8, but I have to divide both sides by 8. These cancel. X is alone. 88 divided by 8 is 11. Does it verify? 10 times 11 is 110. Minus 2 times 11, which is 22. Yes, that is 88. 110 minus 22. I have to be a little careful because the numbers are getting large. But yes, it's working. So combining like terms is another step that you might have to do when you're given these algebra problems. And before we can do these steps that we've been practicing, sometimes you need to simplify a little bit first. Moving down, looking at some more examples. Okay, here's another one. How about I show off by trying to make an example where I'm not being careful to get a really convenient whole number response. So if I just make up my question at random, I'm more likely to get the weird fraction or the weird decimal. But it doesn't matter because we're still able to get the question right and prove we understand our algebra when we do this. So I'm not going to try to make this convenient. How about negative 6x plus 11x minus 2x equals, and this is the part where I'm just making up a number at random, so I really don't know what's going to happen, but I'm going to put 8. Okay, so I'm combining like terms again, but this time there are 3 terms. They all have x, so I can do that. I can't only combine 2 like terms. If I have 3, they're like, I can combine them. They're similar terms. Negative 6 plus 11 is 5. 5 minus 2 is 3. This just turned into 3x equals 8. And now it's like the other examples. I am multiplying my x by a 3. I want to do the opposite, so I'm dividing by 3. These cancel and divide by 3 on both sides. These cancel. X is alone and 8/3. I can write it as 8/3. Or I can write it as 2 and 2/3. Or I can write it as 2.67, which required a bit of rounding because in the calculator it would have said 2.66666666. And when that happens, we do a bit of rounding. 2.67, that's the closest I can get. Interesting. This number, because I had to do a bit of rounding, is not as accurate as either of these numbers. Fractions are better than decimals sometimes, and that's one of the ways they can be better. You can be in a position where your fraction is more exact than the decimal answer you can give, because we don't want to write 666666666. We would be doing it for the rest of our lives. So we need to round that. It's still a good answer because it's rounded correctly. Okay, so that was a different, slightly different combining of similar terms example, a little bit bigger. Does it scare you? I don't expect it to scare you. Here's another one. It's not about combining like terms, but it's to throw some extra steps into the algebra problem. How about 7x minus minus 14 equals 50 plus 30 minus 10. So we have similar terms over here, and they're all constant terms, but not over here. So what do I do first? Well, the first thing I want to do is combine these. I'll make the question easier to write down, easier to look at, easier to solve if I combine the similar terms. So combining similar terms first, when you can, is often a good idea. 7x minus 14 equals 50 plus 30 is 80 minus 10 is 70. Okay, I still can't go ahead and try and make my x be alone because Well, I am trying to make my x be alone, but I'm having to do it in 2 stages because there's 2 reasons x isn't alone here this time. This is the first one I've done today that's like this. My x is having a 14 subtracted from it, but it's also having a 7 multiplied by it. So which one do I get rid of first? And that's something to get used to. I'm going to get rid of the 14 first. So I'm not talking about my x, making my x be alone right now. I'm trying to make my 7x be alone right now. So how do I do that? My 7x has a 14 being subtracted from it, so I'm going to do the opposite. I'm going to add 14 to it. That's the addition one. Sorry, that's the subtraction one that we were doing way near the beginning. But if I'm adding 14 on the left side, I have to add 14 on the right side. These cancel. I'm not finished because my x still isn't alone. But it's closer to being alone than it was before. It has only that 7 with it. It doesn't have the minus 14 anymore. And here I have similar terms again. I have to combine like terms as a step along the way. I already combined like terms, and now I'm doing it again. That happens too sometimes. 70 plus 14 is 84. Now my x is being multiplied by a 7. I want it alone, so I do the opposite. I divide by 7. I divide both sides by 7. What I do on the left side, I do on the right side. These cancel. X is alone, and it's equal to 84 divided by 7, which is 12. Remember the multiplication tables. 7 times 12 is 84. So that's a fast one to do if you know your multiplication tables. Okay, so a little longer. We can create questions that are really, really, really long. And if you patiently apply the rules that you're learning, the rules of algebra, things like combining like terms, finding ways to get your x to be alone, knowing your laws of signs, knowing how to deal with positive and negative numbers, knowing your integers, being able to handle fractions sometimes because sometimes they're there, sometimes they're not, being able to have a decimal involved and still being able to do it. All of this we can do. We just have to be patient. We can't let these bigger, longer problems scare us. I don't want the students to be scared. I'm checking to see how I'm doing for time, and I think I'm doing quite well for time. I think it's finally time for me to get to that division that I was talking about before. And then I'm going to talk about why I think this is so important. I talked about that at the beginning. I'm finally going to get there. So, if my x isn't alone, but it's not having a number added to it or subtracted from it or multiplied by it, it's having a number divided by, well, it's being divided by a number, I should be saying. What do? We're not going to be surprised. My x isn't alone, I want it alone. My x is being divided by a 5. So what do? I do the opposite. I multiply it by a 5. But if I'm multiplying the left side by a 5, I have to multiply the right side by a 5. This isn't so bad. These 5s cancel. And if that seems weird, well, remember, this 5 would be in a numerator. If I want, I can write a line, a fraction bar, put a 1 on the bottom, and turn it into a fraction so that I can see that clearly. The 5 on the top cancels with the 5 on the bottom. 5x divided by 5 is x. We'll get used to it. X is now alone. 10 times 5 is 50. My x is equal to 50. Does it verify? 50 divided by 5 equals 10. Yes, it verifies. How about, I'll do something a little crazy. I'll do the same example twice, but I'm going to use some small numbers so it seems easy. How about x over negative 3 equals 6? Now my x is being divided by a negative number. Should that scare me? I don't think it should scare me. Now there's more than one way to write this, but I happen to have written it so that my x is being divided by a negative 3. Will the trick that we learned work? That negative sign, is it scary? Is it anything to be scared of? Well, what did I learn? If my x is being divided by a negative 3, I want to multiply the x by a negative 3 so that they'll cancel. So x over negative 3 times negative 3, I'll put it like that, equals 6 times negative 3. What I do on the left side, I do on the right side. The negative 3's cancel, and if I want, I can write it as a fraction. If I want, I can cancel the 3's and then cancel the negative signs separately because a negative divided by a negative is a positive. So negative 1 divided by negative 1 is positive 1. I end up with positive 1x. I can write a 1 there if I want, but I don't have to. So I canceled everything. X is alone, and it's equal to 6 times negative 3, which is negative 18. Let's verify. Negative 18 divided by negative 3 is positive 6. It worked. So the fact that I had a negative sign with this number in the denominator, and if the fact that I had a negative sign with the number that x is being divided by did not stop the algebra trick from working. That's cool. I want to do it again, but I'm going to change it a little bit. I'm going to do the same question. I'm just going to write it differently. Negative x over 3 equals 6. It's really the same question. Because with a fraction, if you have a negative sign in the bottom, it means the fraction is negative. If you have a negative sign in the top, it means the fraction is negative. The only way it wouldn't mean that same thing is if you had negative signs in both the top and the bottom, but of course if you had negative signs in the top and the bottom, they'd cancel, like these two did. So, is this changing much? My expression including x, which is negative x, is not that much bigger than an x, but it is. Okay, that's more than just an x. My x, which is negative, is being divided by a 3. So I'm going to do the opposite. I'm going to multiply by 3. But what I do on the left side, I have to do on the right side. So the 6 is also being multiplied by a 3. The 3's are canceling. Negative x equals 18. I'm not finished. Remember, in algebra, you want your x to be alone, and negative x is not alone. Negative x is like negative 1 times x. This x is being multiplied by a negative 1. I want to get rid of that. I want to do the opposite. So I'll divide by negative 1. But that means I have to divide the other side by negative 1. These cancel. My x is alone, and 18 divided by negative 1 is negative 18. Does that show? Yes, it does. I got the same answer. Which way is better? I think that might be a matter of opinion. I certainly took longer and more space to answer this one. I was kind of doing the same thing, but I was doing it in 2 steps. I got rid of the 3 first, and then I got rid of the negative sign. Over here, I got rid of the negative sign and the 3 together at the same time. I think most people would find this more efficient. I just like to do it both ways so we can compare them and think about what we're doing, because the important learning happens when you think about what you're doing. You're thinking about it and you're realizing it still works and it's making you understand it. Understanding is huge. Okay, that was a cool one. I like that one. I'm just taking a quick look at what we have here. Okay, I might go back to do some more multiple step ones soon. Now I want to talk about why I think this is so important. And not just this x is being divided by a number thing. The whole lesson so far. This idea of algebra, basic algebra skills, that we want our x to be alone so that we can answer our question, and depending on whether we're adding or subtracting or multiplying or dividing by a number, we do slightly different things that are all kind of the same thing, because we always do whatever's on the left side we want to also do on the right side. We always do that. So why is this so important? I know it's important because I made a video. I'm making a video right now. I made a video about this. I called it Basic Algebra Skills a long time ago. It was in the year 2007. And I put it on YouTube, and I did not think it was a big deal. I just thought I need a video about this, so I made it. It was for my own students. I just kept putting the videos on YouTube because I couldn't fit all the video files on the computer in my classroom. But other people would watch them, and that was a bonus. It was cool to realize, oh, other people are watching my videos and thinking they're helpful. But there was one video that started being watched by more than all of the others. And it was that Basic Algebra Skills video. I didn't expect that, I didn't plan it. But I asked myself why. That video has been watched about 450,000 times now. It took, it's 2007, it took 16 years to be watched 450,000 times. But I made other videos few weeks before and a few weeks after that have still only been watched 500 times or 300 times. Some of my old videos have only been watched 21 times. So sometimes I realize, okay, well, no one wants that video. But why did so many people want the basic algebra skills video? The answer is because the basic algebra skills are so important. And I should have realized this. I should have expected it. Because I teach students of all different levels. That's my job. I teach all high school levels, and I teach some lower than high school levels. And I have students who are in 10th grade and 11th grade and 9th grade, and so many of my students are having trouble with the math they're learning because they don't know their basic algebra skills very well. Not learning algebra very well at the time that you start to learn it has big consequences, because all the math that you learn after you start learning algebra expects you to remember your algebra. When you move on to higher levels of geometry, they're giving you formulas, and you have to use algebra to solve the formulas, to fill in the formulas and to find out things. But everything, all the different topics in math are expecting you to remember your algebra. So why would so many people be watching that video on YouTube? It's because people who were struggling with their math and were realizing that they didn't understand their algebra very well were going and looking for help. And they were finding my video, and if they found my video and it was helping them because I was doing the same thing I'm doing today, they would watch it more than once. So it was a very popular video. And I was thrilled with that, and I'm still thrilled with it. But it made me really have respect for the basic algebra skills. A lot of students, you can show them one example of each. One addition, one subtraction, one multiplication, one division, and they get it because they're smart students. Oh yeah, I get it. But will they remember it? Because as we've seen, there is such a variety of little steps you have to do. Not many algebra problems are this simple. A lot of algebra problems have a lot more steps involved. So if you haven't practiced the basic skills, you're going to make mistakes. And when you make mistakes, you're all confused because you don't necessarily know where you made the mistakes. Practicing these basic algebra skills is extremely important. Okay, I will stop talking about that, and I will do some more examples. I want to do some more examples where it takes us more than one step to isolate our x. And remember, x is a variable. We could use y, we could use m or n or p or q, or a or b, all of these letters that people like using as variables. You can use any letter for your unknown, but I think it's good to just keep on using x while we're still at the beginning of learning this, because we don't want to be distracted by things that don't matter. It doesn't matter what letter we use for our unknown number, so let's just use x, and then it won't distract us and we can focus on learning the skills. How about 8x minus 12 equals, this is an interesting one that I'm going to do. 4x plus 8. Now, I really made this up at random, so I'm not sure if I'm going to get a clean whole number or some fraction or decimal, but I don't care, because it'll work anyway. So you don't have to always have a whole number, or you can have a fraction or a decimal, that's fine. But what's going on here? I can't combine similar terms here, because they're not similar. One of them has a variable x and the other one doesn't. Same thing over here, I can't combine these. What can I do? How do I get my x alone when there's an x on each side? What I'm going to have to do is start using the algebra skills that I've been using to reassemble things, to get all the x's together on one side and get all the numbers together on the other side. That sounds like a plan. Does it matter whether I put all the x's on the left or the right? No. So, well, we can prove that by doing it both ways. But I will save that for later. If I want to get this 4x, not just the 4, to get the x alone. No, I'm going to get the whole term 4x to the other side. How am I going to do that? I can try to do too many things at once. I don't want to do too many things at once. Right now I'm just going to move this 4x. So the 8x is on the left side, I'm leaving it there. The minus 12 is on the left side, I'm leaving it there. But if I want to get this away from here, I can subtract, I can do the opposite. This 4x is positive, so that's like it's being added. So I can do the opposite and I can subtract a 4x. But if I'm subtracting a 4x on this side, I have to subtract a 4x on that side. Remember the rule. These cancel. Now my 8 is alone, but I have 8x minus 4x. Now I have similar terms that I can combine. 8x minus 4x is 4x, and I still have minus 12. Okay, now it's the minus 12 I want to get to the other side. It's a 12 that's being subtracted, so I want to add. I want to do the opposite. So 4x minus 12 plus 12 equals 8. I added 12 over here. I have to add 12 over there. I have an equation which is equivalent to the one I had before, but it's accomplishing something because the minus 12 plus 12 cancels. Now my 4x is alone on the left side, and 8 plus 12 is 20. I combine similar terms again. So that keeps happening. This combining similar terms keeps happening. Now I'm dividing both sides by 4. These cancel. Whoa, slow down, Doug. Why? My x is being multiplied by a 4, so I'm going to do the opposite. I'm going to divide by a 4. But what I do on the left side, I have to do on the right side. So I'm dividing both sides by 4. These cancel. X is alone. I can't tell if we can see. Yes, we can see that. 20 divided by 4 is 5. I have my answer. It was longer. There were more steps to do. So combining similar terms might not be able to happen with your original equation because the similar terms are on the opposite sides of the equals. But if we use our basic algebra skills to move the terms back and forth so that we can get the similar terms together, well, then we can combine them. And things rapidly start simplifying. And we always end up with one of the basic situations that we've been practicing earlier today. We ended up doing the x is being multiplied by 4, so I do the opposite, I divide thing. Can we verify? Yes. 8x, 8 times x is 5. 8x is 8 times 5. 8 times 5 is 40. And 4x is 4 times 5, so 4 times 5 is 20. Is 40 minus 12 equal to 20 plus 8? Yes, it is. 40 minus 12 is 28, and 20 plus 8 is 28. It verified. So a big crazy one like this, where we couldn't do anything right away, we had to do a lot of preparation before we could start combining similar terms and then doing our basic algebra a trick. What I do on one side, I do on the other. It worked. It was long, but patiently doing the steps in the appropriate order, I'm able to get an answer that makes sense. It verifies. I'm happy about that. I'm looking at my notes again, seeing what do I want to do next. There's not too much more, and in fact, I'm getting to the end of my time limit. It's not a really strict limit. If I go over by a bit, it's okay. Yeah, here's one I like. So I'm going to do an example that's kind of like the one I'm looking at, but I'm not going to use the same example. I want to make up my own numbers. When the students are able to chat with me during the class, I like it when the students make up the questions. I just have to watch out for students who make up questions that are too hard and leave all the other students behind, because some students get so good at this so fast that they only want challenger questions. How about, and because I'm making up my questions at random, I ran out of chalk. There you go, right into the garbage can. Okay, I will replace my chalk. Because I'm making up questions at random, I'll end up getting decimals or fractions, but I just don't mind. I'm not going to worry about that. So I'm going to do this sort of randomly and not try and plan it too much. How about x plus 4? I haven't used 4 enough today. X plus 4 divided by, so now I have what I call a giant fraction because the numerator has a bunch of stuff in it. Divided by, how about negative 5 equals negative 8. There. I can do this. What do I have to do first? My x, I want my x alone, but it both has a 4 being added to it, and it's being divided by negative 5. What should I do first? Should I subtract a 4 or should I multiply by negative 5? I want to multiply by negative 5, and I'll tell you why. Because when I say my x is having a 4 added to it, I can say that, it's true. The only thing that's being added to the only thing the 4 is being added to is the x. But when I say the x is being divided by a negative 5, I have to watch out, because this big long fraction bar tells me both the x and the 4 are being divided by negative 5. So maybe I should, that's more complicated, so maybe I should get rid of the negative 5 first. So I'm going to do that trick first. I'm dividing my expression that includes x, I like to say it that way, by negative 5. So I'm going to do the opposite, which is multiply by negative 5. But what I do on the left side, I have to do on the right side. These cancel. That giant fraction looks scary, but it's not scary anymore because I don't even need to draw the fraction bar anymore. Since I canceled the denominator, that means there's just a 1 down there if you want. It means I don't have to write it as a fraction. I can just write x plus 4. Negative 8 times negative 5, of course, is positive 40. And it turns out that this isn't going to give a crazy decimal answer. It's a very straightforward one, but that's just luck. Okay, so I'm not finished. My x is having a 4 added to it. The opposite of addition is subtraction. So I will subtract a 4 from both sides. These cancel. X is alone. 40 minus 4 is 36. I have my answer. Does it verify? 36 plus 4 is 40, and 40 divided by negative 5 is negative 8. Wow, it verified. That's cool. I have a feeling of power. Math gives me a feeling of power quite often. It's like I could use a calculator for everything, but then it's the calculator that has the power. So the feeling of power is to realize that I can do some pretty complicated things without even needing a calculator. Yeah, that's a feeling of power. Okay. Just want to double check if there's any types of problem that I haven't done yet. I'm going to do a teaser for what we'll probably start talking about a lot, maybe next week, I'm not even sure. But I'm going to do a teaser for one of the tricks that students learn. When you learn tricks in math, that's great. But I don't like it when people rely on tricks too much. When there's a trick, a shortcut, a student who tries to use the shortcut all the time right away is getting into trouble because they're not really thinking about what they're doing. I'm going to slow down and I'm going to try showing one of my simple algebra problems with and without the shortcut, and we're going to talk about it. We're not going to learn a shortcut and just use it without thinking, because that's the sort of learning where you learn a trick without understanding it. You don't understand it because you didn't practice enough, because you're not showing your steps well enough. That's a mistake. But a lot of algebra is done where we don't write down quite as much as I've been writing down. So I'm going right back to one of the really easy ones. X plus 2 equals 8. We know that x is going to be 6. What do? My x is having a 2 added to it. So I do the opposite. I subtract the 2. But I have to subtract the 2 from both sides. These cancel. X is alone. X is equal to 6. I knew that was going to happen. Where's the shortcut? What if I have x plus 2 equals 8, and I say, oh, my x is having a 2 added to it. I'm going to do the opposite. I'm going to subtract a 2 from the other side. X equals 6. What happened to the plus 2 on this side? What happened is that I knew if I subtracted 2 from both sides that they would cancel and my x would be alone. So I immediately jumped to showing my x alone, and I showed the 2 that was being subtracted from the other side. It's a shortcut. People do it a lot. Don't do it unless you're comfortable with all of the algebra skills, all the basic algebra skills. Avoid the shortcut at first. When a student is making mistakes, I tell them stop doing the shortcut. Show what you're doing. Because what's important is that a student who can do this successfully has to realize that they didn't just subtract the 2 from the right side. They subtracted the 2 from both sides. They did this. They just didn't show it all. So watch out for shortcuts. Shortcuts are dangerous. And if you're ever teaching someone else how to do algebra, teaching them this way is going to be more confusing. Teaching this way is better because we can see what we're doing. I like this. I'm in the habit of showing all the steps, and it's one of the things that I find my students like. They like it when I show all the steps. Okay, I think I'm getting to the end of my lesson. I'm going to check the time. Okay, I'm really getting to the end of the time. So I'm going to do one more. I'm going to do a big one just to show my confidence that using all these rules of algebra works. Knowing that it's okay to get an answer that's a decimal or a fraction, that means I can make up a big question where I randomly throw in the numbers that I want to use, and I'll get the answer. I'll get the answer that goes with the question I made. I don't have to be afraid. How about 5x plus 2 minus 7 plus 3x? So we have some similar terms to combine over here. Over 3 equals what should I do here? I'm just going to say equals a half x. And I don't want to write the x down in the denominator like that. I'm going to write it so that you can see it's 1/2 x. Okay, so it's a little bigger than most of the ones that we've done. What am I going to do first? I have the giant fraction. I can simplify inside the numerator of that giant fraction because I can combine similar terms, and I really think I should do that because all 4 of these things are being divided by 3, and if I start trying to mess around with it, I could be in trouble. I think it might be a good idea that I say 5x plus 3x is 8x, and then plus 2 minus 7 is minus 5. Wow, that simplified fast. It got a lot smaller. Now, I have both of these being divided by 3. I'm in that same situation where what I want to do is get rid of the 3 first. So I'm going to multiply both sides by 3. Whew, I have to multiply this fraction numerical coefficient by a 3. That's not so hard. These cancel. 8x minus 5 equals a half x times 3 is 3/2 x. Nothing to be afraid of. If I want to draw the fraction bar, and I remember 1 times 3 is 3, 2 times 1 is 2. That's what I'm doing. Now I want to, I have x's on both sides. That happened again. So what I'm going to do, first I'm going to move the 5 to the other side. What I mean is, I'm going to make my 8x alone because it has a 5 being subtracted from it, so I'm going to do the opposite and add a 5 to both sides. These cancel. I'm running out of space. I'm going to have to move up over here. The 8x is alone on the left side now, but I have 3/2 x plus 5. Whew, this is taking longer than I expected. I want to get these x terms together. So I want the 3/2 x over here. Notice I left a space. I know what's coming. My 3/2 x, I don't want it with the 5 anymore. So I'm going to subtract 3/2 x. Plus 5 is still there. If I'm subtracting 3/2 x here, I have to subtract 3/2 x from the left side as well. These cancel. The right side is very simplified now. Did all of that fit? Yes, I think just barely. Is the plus 5 there? I can't really see. You can see me really well now, eh? Yes, plus 5 fits. Okay, so the 5's alone on the right side now. 8x minus 3/2 x. This is now a little fractions problem. 8 minus 3/2 is 8 minus 1.5. That's 6.5. Another way of saying that is 8 is 16.5. 16.5 minus 3/2 is 13.5. No problem. How do I get rid of this 13.5 now? My x is being multiplied by 13.5. Remember that? We'll multiply it by 2/13, which we have to do on both sides. These cancel. X is alone. 5 times 2/13 is 10/13. A fraction that doesn't even have to be simplified. Not too bad. Looked scary, but wasn't. Patiently apply the rules that we're working on in the correct order. Be careful about the order in which you do things. And even a scary, giant, huge, weird, complicated question like this, in the end you have x equals a number, you have your answer. I got my x alone. But along the way I had to take these 3 different terms that had x and move them around so that I could combine similar terms, combine like terms. But in the end I got my answer. And if we try plugging 10/13 into this position and that position and that position. I don't have time, but if we try to plug it in, it should verify. Let me know if it doesn't. As of now, I am going to say goodbye. I think that's the end of this week's lesson, and it was really fun. I love algebra. Algebra's fun. So I will see you next week. Goodbye.